This is Viterbi Voices, your chance to hear stories about research, classes, student life, and more.
Directly from our students, faculty, and other members of our engineering community. All right here at the USC Viterbi School of Engineering.
Welcome back into Viterbi Voices. I am one of your hosts. My name is Paul Ledesma, Director of Undergraduate Admission here at the USC Viterbi School of Engineering.
And my name is Audrey Roberts. I'm a senior studying mechanical engineering here at USC.
Well, Audrey, good to see you again, back for another one of our episodes. And joining us today is someone new to the podcast, right? Introduce yourself.
Hey everyone, I'm Steven. I'm a junior studying mechanical engineering, and I'm from Orange County, California.
Awesome, Stephen. Well, welcome to the podcast, and thank you for bringing this episode to us. Stephen, what is this episode all about?
Yeah, this episode is about 3D printing. There's an organization at USC called 3D4E, and one of the projects specific to that team is called Project Freehand, and they make prosthetics for children, usually in like downtown LA area.
That's awesome. So they're making hands for kids, and are these kids with disabilities?
Yeah, so usually they were born without a hand, and sometimes even like further than that. So they'll build essentially like a prosthetic that allows them to grasp small objects, essentially.
That is remarkable. 3D4E does a lot of really cool This is just one of the things that they do, right?
Correct, yeah.
And what are some of the other things that they do?
So a lot of the other projects are more year-long projects. They aren't as recurring, but previous teams we've had have 3D printed drones, 3D printed skateboards. There's been more kinetic sculpture related stuff, more artsy things. So it's a very wide range of stuff. It's whatever the club members are interested in.
Well, this is a great episode. I know that we have so many students out there that love 3D printing. They do 3D printing at home. They're printing out pieces of things for their own projects, and I know it's a passion to be able to kind of rapidly create designs. And I know that a lot of you at USC share that passion and have your own organization. And what I think that is unique about this is not only are you doing some really cool work and even making your own printers, this is a really awesome way to give back and to have an impact on the community, and being unique about what the possibilities are for what you can do with 3D printing. So why don't we get out of the way and hand it over to you, Stephen, to take us into this episode all about 3D4E, the organization, and the project Freehand.
Hey everyone, today we're here with Olivia Wong and Christian Hockenberry. They're two team members on Freehand within the 3D4E organization. Would you guys go ahead and introduce yourselves?
Sure. Thanks for having us, Stephen. My name's Christian Hockenberry, and I'm a junior at USC studying biomedical engineering with an emphasis in electrical. I'm a member of Freehand R&D within the 3D printing club at USC, and I'm also participating in ASBME. It's just a general club. So yeah, excited to be on today.
Hi, I'm Olivia Wong. I'm a junior studying health promotion and disease prevention, and I am the lead on Freehand Clinical. Yep.
Awesome. Thank you guys for joining us today. So first, I'd love to learn a little more about 3D4E as an organization. What do you guys do in the club?
Sure. 3D4E is a chapter-based organization, but we kind of are on our own right now at USC. There's about 6 schools participating, and we basically just work around the industry and the technology of 3D printing. We make projects involving everything from skateboards, hands, gadgets, tools, anything you can think of, anything you can really imagine, really. So it's a fun group, and we all get together about once a week and just divide into projects and work on them together. So
it's a very team-based organization. So in the beginning, there's an innovation process where people come up with ideas. And then afterwards, people divide up into teams after pitching those ideas. And throughout the semester, you work on CADing different objects for your project. And then at the end of the year, there's always a showcase where you can see all of the work that people have put in over the year.
Yeah, no, for sure. I definitely remember too, you're part of Free Paw your freshman year. Do you want to talk a little more about that?
Yeah, so my freshman year, I came into the club and I had a lot of experience working at the Pasadena Humane Society in the operating room. And I saw all of these dogs. They would come in hit by cars, and people couldn't afford to take care of them, and they'd have to be put down because the wheelchairs are so expensive. They're maybe anywhere between $200 to $700 or $800. So I came in with the idea of making a dog wheelchair with 3D printing to reduce the cost and also to make customizable for certain dogs. So we found a rescue called Dharma Rescue in Torrance, and we found this bulldog named Frenchie the French Bulldog who had been hit by a car, and he didn't have a wheelchair yet. So we spent that semester getting his measurements, using some files from online for a Chihuahua wheelchair actually, and then we edited those for a bigger dog. And it was great. He was running around in the wheelchair. We made it USC themed. It was a really fun experience.
That's super cool. Definitely, that's one of the aspects I really like about the club. Definitely the social outreach and just doing cool things for the community around us. Getting a little more into what you guys are a part of right now in Team Freehand, do you want to give us a quick breakdown of what Freehand is, what they do, who's it for?
Yeah, so Freehand is a nonprofit organization within 3D4E, but we're a recurring team. So some teams might just do a project for one semester, but we have been going for, I think, I'm not really sure how many years, but I think since 2014. And so we work with Children's Hospital with a hand surgeon named Dr. Nina Lightdale, and she provides us with patients who have hand differences. They're usually congenital. So sometimes there's things called amniotic bands, which in the womb prevents fingers or hand muscles from forming correctly or forming at all. So the children that we work with usually have a functional wrist, but they don't have any fingers. So we actually create prosthetics from this community called the Enable community, and we customize these prosthetics and give it to these children for free. A big aspect of this is self-esteem. So we make the prosthetics as customizable as possible, taking into account what the designs the children want. For example, we did a really cool Iron Man hand one time with a pulsar beam, with electronics, anything the kids want. One girl really liked pink and pandas, so her hand was pink and it had pandas on it. Really, it's whatever they want with that.
That's super cool. And then when you're going about the process, obviously each kid is different size wrist, different size just body parts in general. How do you guys make it where it's actually customizable to their individual hands versus just a general form?
Yeah, so the design of the hand itself we get from the Enable community. We use this design called the Raptor Reloaded, and the initial design of that hand stays the same, but you can enter the specific measurements for the child. For example, if their hand is bigger, smaller, maybe we had one child who had one pinky finger, so we can modify the files a little bit to fit the child's specific needs. And then really the customization comes in with the colors. So you can really make the hands different. Like if a child just wants a plain skin-colored hand, they can do that. But we can also add designs onto the hands, and that's really where the modeling comes in, where we can use CAD to create pandas, or one girl wanted Aladdin lamps, that kind of thing.
Oh, awesome. So then also I'm a little curious about, so you have to get dimensions from them, and I'm guessing you used to do consultations where you'd measure the wrist and different things that you need for it. How are you doing these consultations online now?
So for online, we actually just finished a prosthetic for a kid who we measured in spring, because we had created the hand, but we wanted to do an in-person delivery. But for him now, we're actually meeting tomorrow to see how he's doing, just online. We're actually not allowed to meet in person or anything, obviously. But we have 2 new patients from the doctor that we're contacting right now. And our plan is actually not to do measurements until next semester, if we can be in person. But instead, we're going to focus on the design aspect. So we're going to get into their interests, what they like, and we're going to design these hands to be as cool as possible for these kids, since we have so much time.
Oh, that's great. I think it's really cool to customize it too for kids, especially like having like options. I know you guys in the past have done like a Pokemon based one where it'll be like you put different Pokemon, kind of just keep it exciting for them.
Yeah, that hand was really awesome. Some members put a lot of work into it. So they had, an Eevee or Lucario, different Pokemon, different colors, and the amount of time they spent making those individual characters, because every single time you want to change colors in a 3D printer, you have to physically reload a different color. And so people would literally sit there and watch it go layer by layer, adding one color and then switch it out. And it took hours, but we got, I think, 5 or 6 different Pokemon that the kid can, there's something called a tensioner block right here on the wrist, and the kid can just interchange the Pokemon, whichever one he wants to take to school that day.
So a tensioner block, how does that work? How does it allow them to actually grasp objects when they're using these hands?
Yeah, Christian can talk a little bit more about this too. So it's a string-based system. So basically what happens is you're working with a kid who has a wrist but no fingers. So when they bend their wrist, there's strings that go throughout all of the fingers, and when they bend, the strings are pulled tight with the tensioner block, and then that causes the fingers to close.
Oh, super cool. So what type of objects can they actually grab with these hands? Are they able to grab like water bottles and stuff like that, or is it a little more limited? What's kind of like the span of what they could actually use it for?
So we emphasize that we want them to just pick up light objects with this, like a little plastic bags or something they're holding that's light. They can throw balls with it, like tennis balls. I have one here that I was demonstrating with before to the kid. Basically, anything that's light, they can pick up, but we don't want them picking up any heavy objects with it just for safety reasons.
No, that makes sense. And then also, like, what's your favorite part of just being on Freehand in general?
I think it's definitely just the collaboration aspect. I mean, I'm a health promotion major, so I don't really work with a lot of engineers in my classes. But this experience has really showed me like how health and engineering can be integrated, and the importance of collaboration between these two fields. I think that both aspects of health and design and biomedical engineering, everything, you need all these different people and a diversity of people on this team to make it work. And I think that's really beautiful about the team.
Yeah, no, I think that's great. And I think that's something that's like really unique to our club too at 3D4E is just getting majors from all over. So it's collaboration with engineering. There's fusions of art, health, a lot of different aspects, which makes the club very unique and well-rounded compared to just core engineering only.
Exactly. I think that's the quality of the club. It's the uniqueness on the scope of what we cover. You got everything from different industries and different technologies, but it all kind of just touches on 3D printing. It's not like we're focusing on one specific task. We're focusing on exploring the technology and seeing what we can do with it. And it kind of makes our project scope limitless. We can really do whatever we can imagine we can do with 3D printing. So that's where we're trying to go forward with our club.
Yeah, for sure. And then like now that we're kind of on the topic, and I know you guys on Freehand Research and Development are doing a lot of new technologies. Could you give us a breakdown of kind of what you're working on right now?
Yeah, so in Freehand, there's the clinical side that's working with the patients and making the hands and getting all of the parts together and making sure that they get a quality hand at the end of the day. What we're working on in R&D is really kind of making the hand better, adding little adjustments when clinical needs a really big change for a specialized patient, like they've got extra fingers or it just doesn't fit right. And then on top of that, we're trying to work with different communities on the internet right now. We're working with a group on Reddit that's producing hands and different prosthetics, specifically a shoulder prosthetic, and they're making a new design, and it's all open source, so they want to have everybody join in and kind of make it better. And so we're interested in making a better hand for kids that might not have all that amount of wrist power and they can't really work the current hand that we're working with, the Raptor Reloaded. We want to make another hand, make it more accessible to more people, and that involves implementing new technologies. R&D is part of figuring out what that is and helping develop it.
That's really cool. So you said right now you're working on a shoulder prosthetic with someone through Reddit. How is it working with someone over the internet trying to get like progress on a project?
Working over the internet, it's a lot of collaboration skills and managing your product development. We're really trying to right now to define the scope of where the project's going to go, but within the context of the Reddit community, we're just working and connecting with this person who's put out a design and trying to see if he's willing to have us work on it with him. But overall, we're pretty much focusing on the design process rather than the building. Last year, we were doing a lot of prototyping, like most of the club, iterations of prints and making it better each and every time. But, you know, we're a little bit limited with our access to the lab, and so we can't get in and get our printers working. Some of us have printers, but we're mainly focusing on the design of it, of our hands and stuff. So it's a lot more design than anything.
Yeah, no, for sure. So since you're doing a lot on the design, could you kind of give a breakdown to those who don't, like, I don't really know how a shoulder prosthetic would work. It's like such a limited contact point. How would that actually work to be like give you accessibility to a hand?
Sure. So it's similar in the way that we're thinking about going through a tension-based string system. Right now, the hand is attached to the wrist, and when you move the hand at an angle, it kind of puts some tension on the strings and it's able to close the hand. We want to get that tension from somewhere else, and we're thinking about putting it coming from a different part of the body, possibly someone else's opposite shoulder. This is kind of the different iterations that we're thinking about and developing, where exactly we can put a strap on the opposite shoulder, and if they extend their arm, then the arm would close. It's kind of stuff like that, but we're still including a tension-based system. I myself right now am researching string-based pulley systems so that we can kind of maximize the functionality of the hand without making it too involved. But yeah, we're working through a lot of different ideas with regards to the actuation.
Yeah, no, that's definitely cool. So essentially this prosthetic would be purely mechanical. There isn't really any other components, just a body movement moving, and then it actuates essentially a hand to be able to do stuff.
Yeah, it is just mechanical. At the moment, we're not really putting any in electronics. We have done that in the past, but it's a lot harder to work with electronics and putting it together in the online form. It's just it's hard to work with physical parts like that.
Also, one thing we've noticed about myoelectric hands is that, well, I've actually worked in an orthotic and prosthetic clinic and seen myoelectric hands, really expensive ones. But one thing is that people don't like putting them on children because they're so heavy. And even if you give people a lot of function, the kids tend not to like them or wear them very often. Even if they're able to grab, a glass of water or something, it's not worth it for them because the hand's so heavy. With these body-powered prosthetics, our hands weigh maybe, I don't know, way less than half a pound. It's very light, and I think it's mainly about getting the kid comfortable with the prosthetic. So if we're going to extend this with R&D to a shoulder prosthetic, especially for a child, it has to be lightweight. That's the number one priority for our prosthetic, is being lightweight.
No, that makes sense. And then
Absolutely.
I guess I know you guys have mentioned myoelectric hands a bit. I'm assuming it has something to do with electronics. Could you give us a rundown of what a myoelectric hand is?
Sure. Myoelectric hands are basically, it's kind of a prosthetic device that uses myoelectric sensors to read your EMG values, your EMG. Basically, it senses the magnetic field your muscles create when they're tense. And so if you can have a person flex their muscles in a certain area and you have a sensor read that, you can attribute that reading to them wanting to produce an outcome. And so if you have a sensor on the forearm where they would usually flex if they're trying to close their hand, you can have that actuate either a motor or a linear actuator or something else that closes a hand. And so you can recreate the functional nerve system, nerve muscle, like nervous system, and their hand with the electric robotic hand using the myoelectric sensors. And that's kind of what we were doing last year in Freehand R&D. And we actually did make a lot of progress with our hand. We had just implemented this new actuation device using a twisted string actuator. We had it all kind of put together into a prototype it was kind of a simplest, most cost-effective prototype we could come up with at the time, and it was very light, and I think that it would have done well for the kids that might not want a big clunky hand. It was really small too. We just got a prototype, but then we weren't able to really continue working on it after COVID stuff.
Yeah.
We're kind of transitioning into stuff that we can focus on in the meantime. We might touch on continuing that project in the future, but for now we're focused solely on the shoulder prosthetic.
No, that's really cool. So the way it works, like if I were to grab something with my hand right now, am I using those muscles, the same muscles that the myoelectric hand would sense to close my hand essentially?
Yes, that's possible. There's also a little bit of wiggle room where we can actually change the location of the sensors. So if you actually don't have really good muscle activation in a certain area that would be usually attributed to, operating your hand, we can put the sensor farther up on the arm or in a different spot so that when you do need to close the hand, you can activate a muscle that's, is targeted to operating the hand. So there's a little bit of wiggle room that we have there.
Okay, so it's kind of like if I flex my bicep and it was connected to my bicep, that would cause the hand to actuate and close essentially. And then when you stop flexing, it would open up again.
Absolutely. That's how it works. Yeah.
That's
really
really important
cool.
when you have hand differences. So if they might be missing a part of one muscle, or maybe it can't extend or flex as much as it should. So then that flexibility really lets you get a full functionality out of the myoelectric hand, regardless of what their muscle type looks like.
No, that's all super cool. So kind of just for the future of Freehand, what are you guys seeing that you guys will continue to do, especially in years to come, that's kind of past our time,
I think that the 3D 4E and Freehand group is really going to be looking into the new technologies that keep coming out with 3D printing. Just last year, I think we got an ABS printer, and we were getting some new technologies. We're having people come in and give us kind of their thoughts on the industry. We had people come in from Boeing. We had one of the co-founders of Irby. We had a couple of people come in and really break down the design process, and we're going to be trying to focus on that and implement realistic problem-solving skills with these projects. And that might mean changing the way that we operate with the printers. Right now we've got a lab that's being unused, so we're excited to kind of upgrade the different processes that we're working with.
In regards to clinical, I would say looking into different types of prosthetics. So the man that we mentioned on Reddit who's made the hand called the Maker Hand, that prosthetic is way more functional than the hands that we use now. So the hands that we use now, like I said, you can probably grab a tennis ball and, maybe some very light objects like something the size of, deodorant stick or your phone, something like that. But that hand actually still uses a tension system, but you can grab much heavier objects and you have a much higher range of flexibility with it. And as this technology gets better and continues to be open source, basically, the possibilities are endless. I mean, every year more and more prosthetics come out for free that students like us can print out and really help the community with. So I think the biggest thing for clinical would be, continuing to look out for those new innovations and using the best possible prosthetic available, and also being able to differentiate between the types and use the best type for each specific kid.
No, that's really cool.
Very well
And
said.
you know what would be really interesting and would be a cool thing to explore, and we should, like, 3D4E and Freehand should start reaching out to places, is I know that some companies are working on printers that are essentially making like 3D printed components, but it kind of feels like your skin tissue and stuff like that. And that might be a really cool segue into making these prosthetics instead of it just being straight PLA and like you're having to work around the PLA to make it comfortable. That maybe it'd feel like a much more like flawless connection into like their hands.
Yeah, definitely. I mean, one thing I really want to see in the future, which isn't too far off, is touch. So a sense of touch. So if you touch something with a prosthetic, actually having that transferred to your arm or wrist would be huge, because that's also a big reason why people give up using prosthetics, is because it doesn't feel natural. You can't really tell exactly what you're doing. And a lot of people just adjust with their hand differences and don't really use a prosthetic in daily life, which is also fine. But we just want to give people the most amount of options as possible.
Yeah, that's actually a really interesting topic, and not to like shout out to one of the USC professors' companies, but Professor Dr. Jerry Loeb, he's working, he started SynTouch, and they are developing a sense of touch for industrial robots, and they also apply the technology to prosthetic hands, and they've really gotten the development of artificial fingerprints to create vibrations, and the use of artificial fingernails to kind of measure deformation in the finger, and they can get a really, really accurate reading of what a material is, what it consists of, based on the thermodynamic changes that it happens in the finger. It's almost so good that the technology is actually being applied to vast amounts of industries where they want to figure out what do their products feel like and what do they have it. So it's a real way of kind of quantifying what something feels like. I think that if we were to implement a very simplistic version of that with some of our myoelectric hands, per se, that we could create a really low cost object detection and feedback system for the patient.
Yeah, no, it's definitely like an interesting topic, and just like thinking about it a little further, it's like it's a hard thing though, because like, okay, I touch this aluminum frame or whatever, like I can tell with my hand, but if you have it where it's like a touch sensor, that would have to go back to your brain, right?
Not exactly. It's kind of a hard problem to solve. It's a lot of processing that has to be done to kind of understand and categorize that information. I do believe that the sensor that he's working with is able to kind of quantify different actual metals based on their thermodynamic properties. So that does require a lot of processing power on the sensor though, and if you can implement that on the hand, that would be great, but it's going to add weight to the hand. So it's always a balance of keeping it low tech enough that it's still functional while also trying to get a little bit more tech in so you can make it more functional. So it's a good balance, and that's what's challenging about the way that we're designing these hands to make them better.
No, for sure. And I'm also just like curious in general, like obviously I don't follow prosthetics super closely. How much has that technology like progressed, like aside from 3D printing, just the prosthetic technology itself over the years?
Yeah, actually a lot there's a lot of innovation now with 3D printing, and in the past, I would say 10 years. But before that, honestly, prosthetics from the 50s really looked the same as prosthetics from during the Renaissance. So there was this one guy named Pare who invented a lot of the socket mechanisms that we use, and like, knee joints that can go back and forth. And with hands, there's a lot of hook prosthetics. And that kind of thing has been the same for literally hundreds of years. So now with, it putting in electronics, that's really what's revolutionizing this, but it's all very new. Any of this touch stuff or things that can improve just beyond a basic hook, very new within the past 20 years or so.
Oh, that's super cool. Yeah, no, I don't know why. I don't know if you guys know I'm a surfer, but I was just thinking back to Soul Surfer, the movie, and how when she lost her hand, like the initial prosthetic she got was like not usable, and like it was essentially useless. And kind of, I feel like now there's a lot more, at least development in terms of the sports world too, to allow you to still be able to do the same stuff as you would be with like 2 arms or 2 legs.
Exactly. And that's the kind of realistic take that you have to be approaching these problems with, where it might be great to have all of these abilities, but if it's such a hassle to put the hand on and use it every day, it might not be worth it. So that's what we're really trying to focus on with the shoulder prosthetic, and making a better, more usable device. The more tech you add, sometimes the harder it is to actually get familiar with the hand and how it operates. Maybe Olivia can talk about the way that we kind of help kids understand how to use the hand and really get familiar with it.
Yeah, I mean, it's a lot of modeling, understanding that you have to keep your wrist bent to keep holding an object. That's kind of a difficult concept to grasp. So actually, with the Children's Hospital doctor that we work with, Dr. Lightdale, we're actually starting up a research project involving occupational therapy with the kids. So we're looking to see whether occupational therapy, having them be instructed by a professional how to use the hand and how to grab particular objects. So for example, folding towels is something you can do, picking up a ball or, other things, clay, seeing if they have that instruction over a few weeks, whether that would increase hand function or if it would increase the amount of time they wear the hand for. And that's really what we're looking towards right now. There have been a few kids who have gotten a session or two, but we're really looking to start that research back up right now. And that's really how we're trying to get them to understand how to use the hand.
No, that's really cool. And I think that's the thing a lot of people don't realize when it comes down to prosthetics is how unnatural it feels and how much adjustment it takes to work it into the way you live in your current life.
That's the biggest problem, is that people just don't integrate it into their life, which is fine because they already have a way of doing things and they've been doing it that way for their whole life. So if you try to introduce something new and either it's not doing everything you want it to, or it's just too difficult to try to integrate without resources, that leads to really high levels of rejection. So we're trying to lessen that level of rejection in the kids just by providing them as many resources as possible.
Oh, that's great. It's really, it's so exciting to see how much things have progressed over the years. And then just in 3D printing too, it's crazy to think about, 15 years ago, this was an insanely new technology. And now you could buy a desktop 3D printer for $200. And I know when I talk to people, they're always like, 3D printing seems cool, but it's way too expensive. And now how it's transformed so that a lot more accessibility there is to it.
Absolutely. There's so much more accessibility, and there's so much more education going on regarding the topic and how to use this technology. One of the other groups in 3D4E, I think it was a group of 2 girls, but they were focusing on creating a kind of introductory course to teaching young kids about 3D printing and the technology and how to use it. So they kind of want to increase the accessibility of the technology to people, in the community. And I think that's kind of what one of the main mission goals for 3D4E is. You don't really have to be familiar with the technology. You don't have to be 3D printing stuff and all throughout high school and then come get to college and and then you can get in the club. Like, we accept members who are just interested in the technology, whether or not you've dealt with it in the past. So yeah, we really want to keep moving forward with the technology and see where we can take it.
Yeah, I mean, I came into the club with no experience. I had never used a 3D printer. I didn't know what CAD was or anything. And I think the most important thing is just keeping in mind that how fast the technology is changing. You're really not that behind if you come in with no experience, because you just learn the newest thing alongside everyone else who's learning the newest thing too. And I would say, like, one of the biggest things is just all of the open source material. So for free on the internet, all these prosthetics now that we can use. Just 10 years ago, I mean, that was, incomprehensible. You'd have to go to an orthotic and prosthetic practitioner, get fitted. And if you don't have insurance, those hands could be, $10,000, an insane amount of money. And now the fact that you can get a comparable hand for free on the internet, it's amazing.
No, that's super cool. And it is really mind blowing how much how open source 3D printing is, and how the community is really there to help you out. Like the website Thingiverse, you could literally find, like, you think of something you want, and then someone's probably made it and shared it with the rest of the community. I know, like, this past summer, I was like, we have all these brooms and mops against the wall. Like, this is annoying. So then I just found something online that I could essentially hold these brooms and mounted it to a wall, and then voila, I was like, our house was cleaner. It's just like, it's crazy how much the accessibility to all this information is at no cost. It's just people wanting to help people learn more, essentially.
Absolutely. And it's had a slight impact on solutions, coming up with ways to better manage your mass for COVID. Early in the pandemic, it was pretty hard and difficult to wear a mask for 14 hours a day if you're a healthcare worker. And so I think there was one kid out in the Midwest or something that had the idea, why don't I just make a little device that straps onto the back and kind of holds the tension for the two straps of your mask, so that it's not all in your ears, and you can stay safe, and you don't have to feel fatigued and like you get a headache after a while. So it's such a simple solution, but the fact that it's 3D printed means that all you have to do is click send and send it off to someone else, and they can print it for somebody else. So I really do think that the technology is gonna be helpful in the future.
Yeah, I agree. And I remember, me personally, I was in an industry where I still had to show up to work in person, and it was, oh man, my ears hurt after like the first couple of days. And then I was like, let me see if there's something I could do to make this better. And there I found they're called like ear savers to make it not hurt. So it was definitely like, it's the simple solutions. I think that's what 3D printing is really there for. It really helps simplify small issues right now, but it is working to expand to go to larger scale issues and help with prototyping and all that as well. So it's a really cool industry that has a lot of niches it fits.
Absolutely. And that's another thing that we do focus on in 3D4E. It's not just us doing our implementation of the technology, but it's really looking to the forefront of the technology within the industry. And that's where it was really helpful to have those people come from Boeing and tell us about what they're doing with the technology at Boeing and how it's helping them make bigger and better products. I personally reached out to someone from HP and just asked him a bunch of questions about where the multi-jet fusion printers that they've got over there, what they're working on. They're servicing so many creative people with these printers and the technology that there's people out in Germany making fully customizable prosthetics for very, very cheap prices, and that kind of story is not unique. It's happening all over the world, and I think that the more that we use this technology and the more we figure out what it's capable of, I think we'll be better for it.
Yeah, no, for sure. And I think, I'm just excited to see what's going to come in the next few years and really see, like, we have our whole lives ahead of us to really see how it's going to change. And obviously technology in general is changing rapidly every single day. So it's exciting to see what's going to be coming in the near future.
Definitely. I mean, I would say the biggest thing is just like the amount of kindness people have just putting these things for free on the internet. I mean, they could patent all of this stuff and sell them for, a lot of money. But the fact that, this guy on Reddit who we're looking at the maker hand, that hand is very impressive, holding a weight in a deadlift or all sorts of different things. For functionality wise, that will be a lifesaver for tons of people. And just the fact that it's all online for free is really amazing.
Yeah, no, it's all great. And I really enjoyed sitting down with you guys and just learning more about freehand, 3D printing, and kind of just how prosthetics and just like stuff in general have changed and really grown. So thank you guys. I really enjoyed talking to you.
Thank you so much.
Thank you for having us on.
And we're back. Thanks so much, Stephen, for that episode. I think 3D4E is a really cool organization, and Freehand in particular, like Paul said in the intro, is a great way for USC students to learn about additive manufacturing and give back at the same time.
How long have you been into 3D printing, Stephen?
So I actually got into it, I'd say like halfway through high school. So I started maybe my junior year, and it just started out me making like knickknacks and stuff like that. And then kind of progressed to me making like stuff to make my life easier. Like I made like a caliper for myself and like small things like that. And now it's progressed where I use it for projects that I have at home.
Life's always easier when you make your own calipers, right?
Yeah.
Now, if you can talk to your high school self that was into 3D printing, what is the biggest difference between what you were doing then versus what you're doing at USC as part of 3D4E?
I think the biggest difference is really starting to focus in on the CAD designs and using that. You have to really pay attention to like the tolerances of stuff you're making, and you're making it for like designing an actual product versus like a small knickknack. So I think just like being more aware of like how 3D printing pieces fit together and learning more about that was something I learned a lot here at USC.
Yeah, what type of coursework? I mean, imagine your high school self was trying to make something, and then all of a sudden you took courses at USC in engineering. How did that knowledge immediately translate to stuff that you were designing? Obviously, learning more about some of the CAD software, but some of your approaches to the design, I'm confident that was probably altered a little bit as well, right? Like you're probably looking back at yourself like, I can't believe I tried that back then. Now this is how this works.
No, definitely. Yeah. I think a lot more is you start to understand the technology better and the different technologies you're designing for. So for 3D printing, it's all additive manufacturing, and you start to pay a lot more attention to the way you're going to be putting this on the build plate and how each layer is going to go on top of the next, because you want your first layer to have very good adhesion. So it's going to you want it to be like this flattest layer where you have most points of contact. And then as you're building up, you can't have like a large overhang if you want it to print like well. So essentially you start paying attention like, okay, we're going to make this a gradual overhang where instead of it going straight out in the like X and Y direction without anything underneath it, it'll gradually go so you don't even have to use support. So it's a lot more about learning the technology itself so you could design better for it.
And being more efficient about that design, it sounds like, as well.
Yeah, exactly.
What advice do you have to students that are out there that, they've read about, they've seen YouTube videos on 3D printing, they think it's cool, they don't know how to start, or maybe they don't have the resources to start? What can we share with students on what to do or what to think about now?
Yeah, I think the first part I would really start with is getting into CAD, the technology. It's just computer aided design, and there's plenty of free resources out there. I know Fusion 360 is a free one for students right now, and there's other softwares that you could get interested in and just start learning to CAD. And then hopefully maybe if your high school has a class or there's some community outreach that has 3D printing, you'd be able to actually 3D print the parts you're designing.
Okay, so Fusion 360 is good software to use?
Yeah, it's a great software.
Okay, cool. Awesome. Audrey, have you ever gotten into this?
Yeah, I think so in high school, actually, I worked over the summers at an architecture firm making models. So the cool thing about our models is that they were hand built because it's an important part of the design process, but parts of them are 3D printed. So that's kind of when I got familiar with 3D printing. And then, at USC, through research, I've 3D printed stuff for RPL. One of the subsystems I was working on for really my sophomore and junior year had a lot of 3D printed components. So previously, I know things are kind of shifting because we have a new makerspace for students, but previously we had the undergraduate fabrication lab, which has a super nice 3D printer that we can all use for free. So that makes it easy to just kind of mess around and have some fun with it.
So in addition to my previous question, I also have one more question. Let's say someone wants to get into 3D printing and they want to go get one. Is there like a good model or brand or something that is like entry level to have in the house? I mean, I don't know anything about this. I'm kind of a little more curious.
Yeah, no, for sure. So my first 3D printer, I saved up the money I made over the summer and I bought a Monoprice Maker Select. They now have like Monoprice Maker Select Plus V2. And that was a great entry level printer. It'll cost you around like $300. Another good one is the Ender 3. I think that one's around $200 now. The prices have gone down significantly on household 3D printers. They still will cost you a bit, but it's not like a couple thousand like it used to be.
Cool. Awesome. Well, thank you so much. This has been fantastic. Thanks for bringing this episode, Stephen. Great job on your first episode. And for all of you out there listening, make sure that you are beginning to work on and hopefully start wrapping up that application. Remember, it is due December 1st. If you want to be considered for merit-based scholarships, go to viterbiadmission.usc.edu/apply to make sure you learn a little bit more about our application process and learn more about the deadlines. Or just start the application at commonapp.org. Make sure you add USC to your list of schools. And if you're applying to the Viterbi School of Engineering, you need to list one of the Viterbi School majors as your first choice major on the application. So thank you so much, everybody. Stephen, Audrey, stay safe, stay well. All of you out there, stay safe, stay well. We will see you all very soon. Bye-bye.